In this video, we're going to look at topic 95, example 4, interpret an exponential function. A car was purchased for $24,000. The function y equals 24 times 0.8 to the x can be used to model the value of the car in thousands of dollars, x years after it was purchased. So question A, does the function represent exponential growth or decay? So we have y equals 24 times 0.8x. Remember, that's in the form y equals a times b to the x power. And in this case, b is equal to 0.8. Since b is equal to 0.8, that means b is less than 1. And if you go back to our previous page, exponential decay is when b right here is between 0 and 1. If b is greater than 1, it's a growth model. In this specific problem, scrolling back down, this specific problem, b is between 0 and 1, so this would be exponential decay. And that's all you need to do for a question like that. They're just asking you whether it's growth or decay. The way to figure that out, if b is greater than 1, it's growth, because you're adding a rate. If b is between 0 and 1, it's decay, because you are subtracting the rate, the r value. Okay. In part B, what is the rate of decay for this function, and what does it mean? So b, again, is 0.8, but b is equal to 1 minus r. Again, that's going back to your formula. So b is 0.8, plug that in. We have 1 minus r, and then we can solve this equation. So subtract 1, we get negative 0.2 equals negative r. I didn't give you enough space here. And then that means that r is equal to 0.2. Okay, so that would be the rate of decay, would be 0.2. And what does that mean? Well, 0.2 is the same as 20%. So what that's telling us is that the value of the car decreases, right? That's our decay. So it decreases by 20% per year. Or let's say each year. Let's rephrase that. It decreases by 20% each year. Okay. So to find your rate, you just need to use b is equal to 1 minus r if it's decay, or 1 plus r if it's growth, and then just solve for your r value. So in this case, it was 0.2. And then convert that to a percent, and that'll give you the percent increase or decrease per year. All right, part C, they want us to graph the function on a reasonable domain. What do the y-intercept and asymptote represent? So let's go to our y equals screen, and let's type in our function, 24 times 0.8 raised to the x power. I'm putting the 0.8 parentheses. You can also type it as 24 times 0.8, but for me, this is going to work out. Now, in terms of the window, if I graph this window doesn't really help me very much. So I'm going to click on window here, and I'm going to change my x-min, x-max, my scales, things like this. So in terms of a reasonable domain, we're talking about value of a car, or sorry, years for our x values. So the lowest year would probably be 0. So to give myself a little bit of a buffer, I'm going to put negative 1 as my x minimum. And then for the x maximum, maybe I want to go up to, the graph on the page here goes up to 8. I don't know, maybe I can have this car for, let's say, up to 15 years. But we'll go with 15. You can go 20, you can go 10. It'll just give you an idea. We're just looking to set up some kind of window screen. All right, the scale, I'm going to keep at 1 because I want to show every year increasing. Now my y minimum, think of the value of the car. The lowest that it could be is 0. So my y minimum, I'm going to go with negative 1 again to give you that little bit of a buffer underneath so the axis isn't right on the edge of the screen. And then my y max, well, the maximum value for this car is the initial amount because it's going to decrease. So the maximum is 24,000. The graph on the screen shows us 30. So I'm just going to say 25, and I'll go with that. The y scale, I'm going to go up by 2's, just so there's a little more space. And now if I hit graph, I get a much better representation of what's going on here. Okay, so graph the function of reasonable domain. Your y-intercept is always your initial amount. So I can plot that point as 0, 24, and then everything else I need to look at the graph or the table to figure out. You can hit the trace key, and that'll scroll along the graph for you, and you can pick some points that way. Or you can go to your second table and then pick the points on your way through here. I'm going to use the table, but feel free to use the graph as well. So let's go with year 2. That matches up with about 15. So year 2 and 15 would be somewhere around there. Year 4 is a little less than 10. Year 7 is about 5. Keep that one in mind because we're going to use that in a minute. And let's go with year 6, so 6.2 be somewhere about there. And then year 8 is at like 4,000. Okay, so we're not looking for perfection here. We're just drawing a sketch of this. So this would go something like that. Notice how I'm not going to put an arrow on the top left side, because in terms of this problem, my domain is not going to go past or less than 0. So x would be a minimum of 0. So the y-intercept, what do the y-intercept asymptote represent? So the y-intercept, let's answer the questions here. Now that we have our graph, the y-intercept is 0, 24. That represents the initial amount, or the initial value of the car. The asymptote, all right, so we can't see exactly what it is, but the asymptote is going to be the x-axis. That's not how you spell axis. Or y equals 0. And that's going to represent the minimum value for the car. So eventually the car will be worth $0. In a real life scenario, you might be able to sell some parts for a couple bucks, but here we're just going to say for our purposes, the minimum is 0. And then finally, when will the value of the car be about 5,000? If we look at our calculator, at year 7, matches up with 5, and if we go back to our graph and scroll along, if we trace this, at x equals 7, we do have a y value of just over 5. So when will the value of the car be about 5,000? We can say that the car will be worth about 5,000 after 7 years, not in. We don't know what year we bought this in. The car will be worth about 5,000 after 7 years. It's not 7 years exactly, but an approximation is fine here. So that would be it. These type of problems are usually pretty direct. I don't, like I mentioned a couple times, I don't anticipate a lot of difficulty with this section. You're really just looking at whether it's growth or decay. Your R values are pretty easy to figure out. Honestly, the number one mistake here is plugging in the R value. Make sure you use the decimal version and not the percentage. All right, make sure you always convert percentages to decimals when you're plugging the R value in your formula or your function. All right, outside of that, you should not have too much difficulty with this section. That's all, and good luck with it.